Thank you very much. This is that hard slot, right? Last slot of the day. Everybody's very sleepy. I hope this will kind of be more of an interesting story and the consequences of that rather than anything too deeply technical. So my name's Jacob. I'm a software engineer at NVIDIA. I spend a lot of time spraying code in the general GitHub direction. But I'm not really here to talk about any of that stuff. I'm not going to talk about GPUs or anything. This is kind of me just nerding out about writing Python code. And the kind of subject of this talk is a project called Dask Kubernetes. Now, I'm not really going to be talking about Dask or Kubernetes, so don't panic if those words put you off. But just to give you kind of a bit of an overview, if you've not heard of it, Dask is a Python library that allows you to scale your code out onto many machines. It does this by chunking things up, which is kind of useful if you don't have enough memory and you want to chunk up your data and work through it in pieces, or if you want to spread those pieces out onto lots of machines. Now, if you want to run Dask on lots of machines, you need to start some processes on those machines and tell them to talk to each other. So you log in somewhere, you run a Dask scheduler, you log into other places, you run Dask workers, you connect client, it does stuff. And we've got a ton of projects within Dask that try and make that easier, make that simpler. And that's a lot of what I work on. And a project that I've worked on since about, 2017, something like that, is this thing called Dask Kubernetes. And this is just another Python library that handles setting up a Dask cluster on Kubernetes. And this has been through a few rewrites and a few iterations in that time. And we kind of have a problem, something we've been trying to address for a little while in Dask Kubernetes. And that's that the Python Kubernetes kind of ecosystem is a bit fractured. There's a few different libraries in there. And it's caused our code to get into a bit of a poorly maintained state, right? There's lots of code for interacting with Kubernetes. And for all the different things that we need to do, there wasn't one single library or one single tool that would allow us to do that thing. So, we ended up in one of those horrendous situations where we have lots of dependencies that all do very similar things, and we just use particular features from different ones. And this led to Dask Kubernetes becoming hard to maintain. New contributors would come in, they would want to make a pull request to add some functionality. They would look at a file and, oh, there's 3 different Kubernetes libraries in this file. Which one do I use to interact with the Kubernetes API? What, I want to change this thing. Do I need to replace it? Is there some kind of upgrade going on? What is happening? And that just kind of made it a poor experience for contributors and for maintainers. Now, I don't expect you to read these code snippets, but this is just to highlight, these are 6 places that I chose from within the Dask Kubernetes code base where we interact with the Kubernetes API, and each one of these uses a different dependency, each one of which has a different kind of auth flow, so they're all authenticating independently with Kubernetes, not necessarily consistently, even though we're interacting with the same Kubernetes cluster. We can have all sorts of funky edge cases and bugs and things, just because we're doing so many different things. Now, some of these libraries are Python libraries, like Kubernetes and PyKubeNG. Some of these are just, I'm going to use subprocess, and I'm going to call the command line tools for interacting with Kubernetes, which is called CubeControl. And then there's even better, there's PyTest kind, which wraps up CubeControl. So these CubeControl via subprocess and CubeControl via PyTest kind, that's not even the same CubeControl. One of the ones is the one that it found on my path. One of the ones is the one that came bundled with it. So these could be different versions of CubeControl. Bad times. Now, to try and deal with this, my first instinct is to kind of go through and evaluate all these libraries. Why have we gotten in this state? Why are we in a situation where we have so many different versions, so many different libraries for doing roughly the same thing? Is there one that can actually step up and replace all of these things? And typically, each one had very valid pros and cons in this situation. The actual Kubernetes library is an auto-generated library, like all of the Kubernetes kind of client libraries that aren't the Go one. They've taken the OpenAPI spec, they've put it through an auto-generator, it spat out a load of code, they put that on GitHub, and it's got thousands of stars. And it's not the most pleasant thing to use because it was not written by a person. It's not designed for Python, it's just designed to be an API library. And one of the things that we have in Dask is we use Async I/O a lot, and it doesn't support Async I/O. So there's another library called Kubernetes Async I/O, and this one uses a similar generation technique, but just a slight different flavor that gives you an Async I/O compatible library. Both of these kind of have varying levels of documentation. Often if you want to do something in Kubernetes Async I/O, you go and look at the Kubernetes documentation and then try and do mental translation into what that would look like in Async I/O world. And then other folks have tried to tackle this, so there's other libraries like Crates and PyQubeNG, There's other libraries for doing kind of more specific things like COP, which is great for building operator controllers, which I'm not going to talk about, but COP is an awesome library, but it's kind of niche in the Kubernetes space. And then, CubeControl can do all of these things that we want to do. It does absolutely everything, but it is a binary on my path. I can call it with subprocess. I can mush that up with layers of abstraction if I want to, but ultimately, I have a binary dependency in my Python library, and that kind of makes me sad, because that's hard to deal with in the Python space. I can't force you all to use Conda as much as that would make my life easier as a maintainer. So, what I would want to do to try and fix these things is, can I, as an enthusiastic open source contributor, go to these projects and fill in the gaps, fill in the pieces that I need? This is kind of my natural instinct. It's a lovely space working on GitHub, being able to just go in and fix and add these things. But over the last few years, as we've worked with these libraries and as we've done different things and as we've tried to fill in various gaps, actually getting the changes that we want into these libraries doesn't make sense, right? Contributing to auto-generated libraries has a lot of resistance because you can't make changes to the auto-generated bits. You can add like wrappers and things. If anybody's interacted with AWS, you have Boto Core and Boto 3, and those kind of have this relationship of auto-generated and then human wrapper. But Kubernetes doesn't have that equivalent. Other libraries are kind of either unmaintained or, like I said, they're niche or outside of the scope of Python. And so going through all of these different libraries, there just wasn't a way for us to get the features that we needed in Dask into these libraries. So, okay, I'll have to cross off contributing, as sad as that makes me. So then the next thing for me to think about is, okay, can I wrap these things? Can I at least try and fix the contributor experience in Dask Kubernetes by giving contributors and developers the tools to work with Kubernetes in a way that doesn't feel painful? Should we have some submodule inside Dask Kubernetes that kind of gives this kind of better API, this consistent API, and we'll abstract all of this crazy mess? I'll put in some kind of shim. That seems like a reasonable approach that happens in lots of places. And so this is what we did. This is how we tackled this. I wrote a wrapper called AIO PyCube because PyCube is my favorite API out of all of the APIs. And I thought, okay, I'll wrap that, and then I'll add the missing bits and pieces using the other libraries. I'll expose it through an async interface so that we can come along and do all the async things we need to do. And I'll document this in Dask Kubernetes, and we'll put this in our contributing guide, and people who want to work with our library can come in, they can use this wrapper, they can have a better time. But this was also really messy. I don't know if anybody's tried wrapping sync code with async IO to try and make it asynchronous. That gets very out of control very quickly. And one of the main things that I found doing this is PyKubeNG uses requests under the hood, and we just wrapped that with running those synchronous blocking request calls on in a thread pool executor and exposing that through async IO. And then when we wanted to do more interesting and funky things with requests, like open WebSockets and interact with things over a WebSocket, all of a sudden that design was poor, and it was a poor experience for us to use. And so we put this other library in, tried to use it, and ultimately this felt like a bad decision. So this was a good opportunity for us to say, okay, let's stop. Let's not try and force this. Let's not try and make this work. We can't use this. We need to back out this code that we've added. And I just found myself sitting there thinking, CubeControl does all the things I want. I don't want a random binary in my project. I don't want to be calling a subprocess, but it has the API that I want. It has all the features that I want. CubeControl is written for people to type into a machine, and CubeControl is written for you to use in scripts and things. Okay, it kind of is natural to use CubeControl. The Kubernetes API is very much not for people to interact with. Right? It is much more complex. It is much more verbose. CubeControl is this nice friendly, friendly in loose quotes, but it's this nice friendly wrapper on top of the API to try and make it more easy to use as a human. And me as a human writing Python code for Dask, I just wish I had that KubeControl experience. So you can maybe guess what is coming next. I mentioned some of my colleagues, I really wish this thing existed. There's a thing I would really like to exist. Now, I spent the first 10 years of my career enthusiastically making things, and I'm probably going to spend the next 10 years of my career enthusiastically trying really hard not to make things and get rid of the things I've already made and try and simplify it and reduce. And I think that is something that everybody comes to eventually. But I was at this point where we need a thing, and we don't have that thing, and we're in a bad state, and things are not okay. I think I want to make a new thing. But I want to be cautious about this. I want to think this through. And I'm hoping that is the message of this talk, of like, When you want to build a new thing, there's lots of valid times to build a new thing, but think it through. So, lots of people sent me this. I've seen this comic a bunch of times, but everybody that I said, I think I'm going to build a Kubernetes library, were like, no, don't. There's lots of Kubernetes libraries. Use one of the existing Kubernetes libraries. We had the conversation that I've just had with you, and we kind of relaxed a bit and moved on to, okay, what would we like? If we actually were going to sit down and write some requirements, what would we like out of this new library? And ultimately, I want the user experience of writing code in this library to be pleasant, because I want people to come and help me work on Dask. So if any of you want to work on Dask, come and help me work on Dask. But I want this to be a pleasant experience. I want a pleasant API. I don't want to be using auto-generated code. I don't want to be using undocumented libraries. I don't want to be using subprocess. I want just a nice library that we can come along, we can all play, and build Kubernetes stuff for Dask. We also do a lot of async IO stuff in Dask, but sometimes we need sync code. It'd be really nice if it could do both. And I want to get away from this auto-generated stuff. Now, the auto-generated libraries, they do a lot of like client-side type checking of all the different objects and all the different things you're creating for Kubernetes. And that's great and it's very correct, but sometimes it gets in the way. It's kind of the Go side of Kubernetes is spilling over into Python world, and it feels extremely rigid in many cases and extremely verbose. And it's not Python types, these are, messy. So I want to get away from that auto-generated code as much as possible. I want to rely on the API to tell me that I'm doing the wrong thing. And also, I haven't shown much code here at all, but with all of the existing methods, apart from CubeControl, I have to be really explicit about, I have auth credentials, they live in this file, I want to load them, I'm going to create a client object. I now have a client object, I'm going to give that to every method that I'm ever going to call ever. I have to be really explicit with authentication. Whereas CubeControl follows kind of a path, it looks for your credentials, it loads it, it makes assumptions, you can give it extra flags to change things. But it's just a bit more frictionless to authenticate with KubeControl. And it's like, well, it'd be really nice if we did that out of the box. If we just looked at where KubeControl looks for credentials as our first port of call, if you don't tell it what to do, and then give you some keyword arguments to set those things, that seems better than making you make all these objects all the time and pass them around all over the place. And then the last thing is, basically none of these libraries had these advanced features. It's like API features of Kubernetes, but like not fully implemented. And port forwarding is one of those examples. So if I do kubectl port forward some container in my cluster, it'll map the port on the container to a port on my laptop, and I can access the service, right? But in all of the Python library implementations, it will open the HTTP request to the Kubernetes API to start the handshake for doing that, and then it will give you the request object and say, off you go. And there's like a whole protocol for speaking to the Kubernetes API and doing this port forward and doing the handshake and transferring data back and forth. None of this is implemented in any of the Python libraries. But it is implemented in KubeControl. It's one of the reasons why we had KubeControl in our project, is because we didn't want to write all of that. So it was like, well, why can't we have a library with these things in? Why can't we build these things out? I mean, one of the reasons is because none of this stuff's documented, and to figure all this out, I had to dig into all the Go code to figure out how the handshake worked, but we got there. But then after thinking about what would this new library look like, I wanted to take a step back and be like, that sounds great, but what do I want? What do I need? What is my actual problem? My problem is that Dask Kubernetes is not very maintainable, and contributors are having a bad time, and that I'm using all these libraries and they make me sad in getting my day-to-day work done. And then also, like, I want to understand things like this handshake and how this port forward works. I find it personally interesting. I like Kubernetes. I want to learn more about it. Building a library would be a great opportunity to do that. Even if we never use it, I would just kind of like to dig into that for a personal interest. But I also wanted to write down some non-goals, right? And I think this goes back to that xkcd, is that xkcd is about standards, right? There's a load of standards. We should unite everybody under one new standard, and then there's a load of standards plus one, and that goes round and around. In this case, I wanted to be really explicit. I don't want to create a new standard. I don't want to create another Python library and get everybody to use it. I just want to create the library that I need that helps me solve the problems that I have in Dask Kubernetes. And if it becomes another tool, like we have these other niche tools in the Kubernetes space, then that's awesome. So I made this project, and it's called Crates. And I was kind of reluctant to do it, and that's kind of what I want to communicate to you. I reluctantly built another Kubernetes library because I thought it was probably the right thing to do after spending years thinking about, should I do this? And it feels like KubeControl. That's the intent, right? As a developer, you come along, if you've used KubeControl before, Crates should feel good. You shouldn't have to learn new things. And just to highlight that, at the top is the Async Kubernetes library. At the bottom is Crates. It's just much simpler, it's much leaner, and it feels like CubeControl. And so we started chugging through all of this code that we had in Dask Kubernetes, putting crates in, simplifying, and this was so satisfying, right? All of these diffs where we were just deleting code all over the place. This is what I want to do, this is what makes me happy. I know I had to make a library to do this, but that felt like I was putting the world in order, right? So we're going through Dask Kubernetes, simplifying, reducing, removing dependencies, removing libraries, pulling things together and making things more readable, and that was awesome. And then I was having a chat with another colleague, and they turned to me and said, "Oh, Crates looks great. Have you seen LikeCube? That's cool as well." And I had a bit of a look, and I was like, "Yeah, I have seen LikeCube. Why have I seen LikeCube? I did some research at the beginning of this. I looked into alternatives. I didn't find alternatives. Why did I not see LikeCube?" I was like, "Oh yeah, there's a big notice on the thing saying, this is a toy project, don't use this, I'm experimenting, I'm exploring." I think at the point I took this, maybe this notice had been watered down a little bit from the first time I saw it. But I kind of just bounced off this project as like this isn't ready, this is somebody else playing, I'm gonna go and play. But then we got to a point where, looking at the code, they are very similar in design, right? They both are trying to solve the problems that the core libraries solve. And writing the same thing in both libraries looks quite similar. So I came to this really interesting decision point of like, I spent a couple of months on this, kind of off and on, it's a side project, it's a back burner project, and we're partway through a migration in Dask Kubernetes. Do I abandon Crates? Does Crates go away? Do we just use LikeCube? And ultimately, I decided to continue, and we'll talk about that in a minute, but this was being able to step back and reflect on this and say, do I really need to build a new thing? There might be a thing that does this. Does this solve my problems? Does this meet my requirements that I had before? And but the fact that I'd written these things down and talked to people about these, it really helped me understand, does LikeCube solve these problems? And digging more and more into it, like there was quite a lot of differences, and LikeCube has all these things in it about auto-generating these models in the same way the default one does, and it's got a tight bond with the version of Kubernetes you're using. And ultimately, it was trying to be a better version of Kubernetes and Kubernetes Async I/O. It wasn't trying to be CubeControl in Python. And so I decided to carry on and push forward to try and achieve these goals that I was trying to set out to simplify our code for our contributors. But I felt uncertain, right? And I think this is like a good feeling to have, is like, am I doing the right thing? I'm building a new thing. Is this a good way? Is this a good route to go down? And I wasn't really sure, and that was kind of where I got to with preparing this talk for here, to come along and say, I built a new thing, I'm not sure this is the right thing to do. These are kind of the things I've thought about, this is how I've kind of written things down, this is how I've set my requirements. And I'd kind of written up this talk and ready to come and talk to you. And then about 10 days ago, I was just kind of sharing the link around, and I put it in a few different places, and I was talking to different people about it. And Crates ended up on the front page of Hacker News. And that was like super exciting and extremely terrifying at the same time. But this is the number of stars of all of these projects we've been talking about and comparing, plus some other projects that I just hadn't even heard of that came up in the Hacker News comments, like the OpenShift library, which turns out is also a Kubernetes API library. It's just not listed anywhere or advertised as such or named as such, but it is. But in kind of like 48 hours from it hitting the front page of Hacker News, Crates rocketed up to being the second most starred Kubernetes client library on GitHub, only behind the official auto-generated one. And it's bypassed everything else. I now seem to have a bunch of users, people who like this KubeControl approach. So what I kind of want to share with you is we made a decision to build something from scratch. And there's a bunch of things we were thinking about, like, can we contribute? Can we wrap? Do we need something that's a fundamentally different paradigm? What else is out there? Can we research? Can we explore before just jumping in and building things, which is what I would have done 5 years ago. But also keep in mind, don't be scared to throw that thing away again if something else comes up, or if something's gone wrong at some point. It's okay to discard work, because in the future, you're going to be bound by these things. You have this debt of code that you've created, and you probably don't want it. So maybe I'll kill Crates one day. There's a few final thoughts here. I do have Crate stickers, if anybody wants a cute little sea snake sticker. And I also started writing a blog post. I put a link here because there's like a ton of thoughts, and this talk is a bit of kind of like a weaving pattern. So a lot of this is written out in this blog post. I pressed git push before. Hopefully the CI will that will exist at the time I'm talking, but you never know. Thank you very much.
No?
Is there anything else you're planning on rewriting?
Sorry, I didn't actually hear that. It's quite echoey.
Is there anything else that you are planning on rewriting?
Oh, I don't know. I mean, I build too many Python libraries. That's kind of a personal character flaw. I'll probably rebuild Dask Kubernetes again at some point. It's only been about 9 months since I've done that. So, yeah, no, I don't know. But every time I do it, every time I think about it, I want to try and be more and more rigorous every time with why we should do this and why we want to, why existing things aren't suitable. But also accept the fact that existing things have baggage, they have designs from the past that may not be applicable to what we need now, or they may not be exactly what we're trying to do, right? A lot of this was about user experience or like contributor experience over like technical correctness in some situations. So yeah, I don't know. I'm sure I will rebuild more things.
Anybody else for any questions?
Thanks. Do you think an auto-generated library can ever provide a really good developer experience? Or was this a problem with the Kubernetes library specifically?
I think an auto-generated library can never provide the same experience, but I do like the model that AWS have gone with having an auto-generated library and then another library that uses it as a dependency to try and then smush that into something that's pleasant to use. And like, it's kind of tricky. Kubernetes is such a well-defined thing, like the back end and the spec is so well-defined, like auto-generation makes a lot of sense. And there's tons of situations where Lightcube would be the right choice. And this is kind of what I'm saying. I don't want crates to take over as like the popular thing. Like if you care a lot about the things that Lightcube gives you, please go and use Lightcube. I added to and from Lightcube methods to everything in crates in case you make the wrong choice and you need to go back and forth, and and for the other libraries as well. But yeah, I think auto-generation, it gives you some things, but it's lacking a lot of other things that you still need to add, and it's when these libraries don't add those things, make things feel Pythonic or make things feel nice to use, that they struggle, like the Kubernetes library does a bit.
We have time for one final question. Anybody?
While the microphone's moving, Crates is at like 486 stars or something. So if you want to get me to 500, go and press it. I guess that's exciting.
Who was it?
Hi, thanks for that. I'm quite curious, did you feel, so for most of us I think we see command line tools as very different from libraries that we interact with when programming. How did you feel like that mapped, taking the sort of the design of a command line tool and trying to turn that into something that you use in structured code?
Yeah, so command line tools are interesting because they're like primarily intended to be typed in by people interactively and interact with other things. So there's like a lot of thought goes into like different areas of kind of succinctness in how you interact with it and kind of readability in a single line. But then also like CubeControl is really good in that it can output JSON or YAML and you can feed it into other tools, and it's kind of nice as like a scripting tool or as a library in other things. And it's not as kind of descriptive as other libraries. But I think what I was trying to achieve is like if you do CubeControl get pods, it will list the pods. If you do CubeControl get v1/pods, it will look up the API and it will get pods. If you do CubeControl get PO, It will know that you mean pods because it's got a shorthand mapping and it will look that up. All of those things have been added for like convenience, right? So that you can be explicit or you can be lazy, and it all kind of works. And so that's the essence that I wanted to capture in the Python library, is like you can do crates.get, string of po, or crates.get a string of v1/pods, and be as explicit or implicit as you want to match that experience. Woo! Thank you very much. 500.